Hello, welcome back to NEET Prep Go. So today we'll be doing amines, which is a class 12th chapter, NCERT line by line. Without any further ado, let's get started. The chief commercial use of amines is as intermediates in the synthesis of medicines and fibers. The chief commercial use of amines is as intermediates in the synthesis of medicine and fibers. So amines are, that is commercially used, that is chief commercial use of amines is as intermediates in the synthesis of medicines and fibers. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl group. So basically your ammonia molecule NH3. Okay, so how is amines, what is amines? Basically amines are an important class of organic compounds. They are an important class of organic compounds which are derived by replacing one or more hydrogen atoms. So there are three hydrogen atoms of ammonia, right? So amines are a class which are made by replacing one or more hydrogen atoms of ammonia molecule by alkyl or aryl groups. So by alkyl or aryl groups. In nature, they occur among proteins, vitamins, alkaloids and hormones. So in our nature, amines occur among proteins, vitamins, alkaloids and hormones. Synthetic examples include polymers, dyestuff and drugs. Two biologically active compounds are namely adrenaline and epinephrine. Both contain secondary amino group. They are used to increase the blood pressure. Novocaine is a synthetic amino compound. It is used as an anesthetic in dentistry. Benadryl is a well-known antihistaminic drug which also contains tertiary amino group. Quaternary amino salts are used in surfactants. Diazonium salts are intermediates in the preparation of a variety of aromatic compounds including dyes. In this unit you will find salts. Okay. So let's go through once again. Amines, commercial use of amines is as intermediates in making medicines and fibers. In synthesis of medicines and fibers, amines constitute a very important class of organic compounds which are derived by replacing one or more of the hydrogen of the ammonia group by alkyl or aryl groups. So one or more hydrogen atoms of the ammonia alkyl or aryl groups. In nature, they occur among proteins, vitamins, alkaloids and hormones. In nature, amines occur among proteins, vitamins, alkaloids and hormones. What are the synthetic examples of amines? The synthetic examples of amines include polymers and drugs. Synthetic examples of amine include polymers, dyestuff and drugs. Two biologically active compounds named adrenaline and epinephrine to increase blood pressure, and both contain secondary amino group and both are used to increase blood pressure. Both contain secondary amino group and both are used to increase blood pressure. So adrenaline and epinephrine both have secondary amino group and they both are used to increase blood pressure. Then novocaine. Novocaine is a synthetic amino compound which is used as anesthetic in dentistry. And Benadryl is a very well-known antihistaminic drug which also contains tertiary amino group. Quaternary amino salts are used as surfactants and diazonium salt is used as an intermediate. Diazonium salts are intermediates which are in the preparation of variety of aromatic compounds including dyes. And in this unit we will learn about amines and diazonium salts. Amines can be considered as derivatives of ammonia obtained by replacement of one, two or all three hydrogen atoms by alkyl or aryl groups. For example, if we replace one hydrogen and we put CH3, then it is CH3NH2. Then instead of that is methyl, you can put ethyl also, C6 sorry, you can put benzene group, you can group aryl also, that is benzyl. This is benzyl also you can put. you can put 2 CH3 on both sides, or it can be tertiary also. This is secondary and this is tertiary amino. Wait a second. So amines can be considered as derivatives of ammonia, and we get amines by replacement of 1, 2 or all 3 hydrogen atoms by alkyl or aryl groups. So firstly CH3NH2, that is if we replace one hydrogen by methyl group, then we get CH3NH2. If we replace that one hydrogen by benzyl group, then we get C6H5NH2. We can replace two hydrogen, then we get secondary amine, that is CH3R R2NH2, sorry R2NH, and tertiary amine, that is R3N. So like ammonia, nitrogen atoms of amines Like ammonia, nitrogen atom of amines is trivalent and it carries an unshared pair of electrons. So just like ammonia, the nitrogen atom of amines is trivalent and it carries an unshared pair of electrons. So it is going to be like this. Nitrogen orbitals in amines are therefore sp3 hybridized. It has one lone pair and three bond pairs. So therefore it is sp3 hybridized. Nitrogen orbitals in amines are therefore sp3 hybridized. The geometry of amines is pyramidal. What is the geometry of amines? Geometry of amines is pyramidal. Each of the three sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon depending upon the composition of amines. So each of these three hybridized orbitals of nitrogen, they overlap with orbitals of hydrogen and carbon depending upon the composition of the amine. The fourth orbital of nitrogen in all amine contains an unshared pair of electron. The fourth orbital in all the amines is going to contain an unshared pair of electron. And due to the presence of this unshared pair of electron, the angle CNE, where E is either carbon or hydrogen, is less than 109.5 degree. For instance, it is 108 degree in the case of trimethylamine. So if we take tertiary trimethylamine, that is CH3, here there will be an unshared pair of electrons. So due to this unshared pair of electrons, the angle is always going to be less than 109.5 degrees. So it is going to basically shorten, right? So if you see, then this unshared pair of electrons, the angle is always, in this trimethylamine, the angle is 108 degree. So it is always going to be less than 109.5 degrees. And this is a pyramidal shape. Pyramid shape. Classification. Amines are classified as primary, secondary and tertiary depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecule. If one hydrogen atom of ammonia is replaced by R or AR, then we get RNH2 or ARNH2, a primary amine, that is a primary amine. So by alkyl group, if we replace it, then we get RNH2, aryl group ARNH2. Okay, so amines can be classified as primary, secondary, tertiary depending upon the number of hydrogen atoms which have been replaced by alkyl or aryl groups. A primary amine is RNH2 or ARNH2. If two hydrogen atoms are replaced, then what would you get? That is RNHR or R2NH, secondary amine. Then second alkyl aryl group may be same or different. Replacement of another hydrogen atom. So these two are, it can be R-R or it can be RR. That is, it is up to you. Then replacement of another hydrogen atom by alkyl aryl group leads to the formation of tertiary amine. Amines are said to be simple when all the alkyl or aryl groups are the same and mixed when they are different. So replacement of another hydrogen atom by alkyl or aryl group, that is if you replace this hydrogen also by alkyl or aryl group, then we get tertiary amine. So see, this is your ammonia molecule. You replaced one hydrogen, you got RNH2, primary amine. You replace the second hydrogen also, you got R and another different R you have taken, let's say R dash, then you got secondary amine, and then lastly you replace this third hydrogen also and you took another different. So in one case you took CH3, in one case you took C2H5, in one case you took, let's say, C6H5, or aryl group you took. So R dash dash. So then you got tertiary amine. Amines are said to be simple when all the alkyl or aryl groups are same and different when they are different. So in this case, if I have taken 3 R's, and this is R dash, and this is R dash dash, and let's say all of these three are 3 different groups, then we will call this as one mixed amine, because all the alkyl, that is alkyl or aryl groups, they are all different. If when they are all same, then we'll call it simple amine. Now nomenclature. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkylamine. One word. Example, methylamine. In secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is appended. So, in common system, an aliphatic amine is named by prefixing alkyl group to amine. So, alkyl amine as one word. Example, if I write CH3NH2, then I can simply write this as methylamine. In secondary and tertiary amine, when two or more groups are same, the prefix di or tri is appended before the name of alkyl group. So if I write NCH3NH, CH3, CH3, then I can write dimethylamine. This is common name, not IUPAC name. That is, in common name we can simply write as alkylamine, that is methylamine. If two, then dimethylamine. If three, tertiary amine, then trimethylamine. In IUPAC system, however, amines are named as alkane amines. Alkane amine. So methanamine, ethanamine, derived by the replacement of E of alkane by the word amine. For example, CH3NH2 will be called as methanamine. In case of more than one amino group is present at different position in the parent chain, their position are specified by giving numbers to the carbon atoms bearing NH2 group and suitable prefix such as di, tri attached to the amine. The letter E of the suffix of hydrocarbon part is retained. For example, NH2, CH2, CH2, NH2. It can be named as ethane 1,2-diamine. Okay, so here there is one amine, then CH2, CH2, then again NH2. So here we'll write first this, that is ethane, then 1,2-diamine. If more than one group is present, then your E is retained. Otherwise, if it would have been, wait, if it would have been C2H5NH2, then I would have said ethanamine. Ethanamine. there would have been no E. Instead of E, I would have written amine. But when there is a secondary amine, then for secondary amine, IUPAC name E is retained. So ethene 1,2-diamine. In aryl amines, NH2 group is directly attached to the benzene ring. So NH2 group is directly attached to the benzene ring. It is the simplest of example of aryl amine. In common system, this is called as aniline. You all must be knowing. This is called as aniline. It is also accepted as an IUPAC name. So this aniline, that is when directly NH2 gets combined with the benzene ring, then we call it aniline, and it is accepted as an IUPAC name also. While naming aryl amines according to IUPAC system, suffix E of arene is replaced by amine. Thus, for this, we can say either aniline or benzene amine. Instead of E, we will write amine. Benzene amine. Common and IUPAC names of some alkyl and aryl amines are given below. CH3, CH2, NH2, ethanamine, and common name ethylamine. And CH3, CH2, CH2, NH2, that is propanamine, also called as N-propylamine. N, why we are writing? Because if I put this NH2 over here, then it will become iso. If I put it in the middle, then it will become tert. See, the same thing. Here I've put NH2 isopropylamine or propane 2-amine. Then over here I put NH, that is 2 I have put. So ethyl, so if it would have been CH3 CH3, then I would have said dimethylamine. If it would have been CH2 CH3 and here also CH2 CH3, I would have said diethylamine. Since the one part there is CH2 CH3 and one that is CH3, and we know that E comes before M, so therefore ethyl methylamine. And next is N-methyl N-methyl ethanamine. So here there is one group, and then from nitrogen we'll see N-methyl ethanamine. Then over here this is trimethylamine, tertiary, 3 degree. This is 2 degree. These are all 1 degree. Trimethylamine, this would be NN dimethyl methanamine. We are going to consider methanamine only, rest will be then next N-dimethyl butylamine. So C2H5, C2H5, diethyl, NN diethyl butylamine. Here NN diethyl butane 1-amine. So instead of butylamine, it is butane 1-amine. Then allylamine, NH2 CH2. This is important. NH2 CH2 CH double bond CH2 is allylamine. Prop 2-ene 1-amine. Then here it is hexamethylene diamine. This to you know, benzene ring, NH2 attached to benzene ring, aniline, IUPAC name aniline is also accepted, so is benzenamine. Over here there is 6 carbon 2. When there are 2 nitrogen group, then it is hexane 1,6-diamine. 1 nitrogen group, then we will use NN. That is the position to which it is attached to at H2 is basically important. hexamethylene, hexamethylene diamine, orthotoluidine. This is toluene, and NH2 is also there, amine, so toluidine. Here methylalanine, aniline. Then parabromoaniline, 4-bromobenzenamine or 4-bromoaniline. Then NN-dimethylaniline, NN-dimethylbenzenamine. This is 1 degree, this is 2 degree, this is 3 degree, this is 1 degree. You can see by how many hydrogen have been replaced. Preparation of amines. How are amines prepared? Amines are prepared by the following method, that is reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to corresponding alkane amines. So that is, these nitro compounds can be converted into aniline. That is benzenamine in the presence of hydrogen and passing by hydrogen palladium and in the presence of ethanol. Similarly, Sn plus HCl or Fe plus HCl also will give the same reaction. Iron scrap and hydrochloric acid.